Good afternoon. So we'll start.
Good afternoon, sir.
So we have covered already selection sort, bubble sort, insertion sort. So these three were sorting technique, and now today we'll start this linear search, binary search, merge sort, and quick sort. So let's see. I will try to finish all four today. So there are two searching technique, linear search and binary search. So there are two more sorting technique like merge sort and quick sort. Okay, then this part will be finished, and tomorrow we may discuss assignment or something. I may share some questions for you. Or for the revision thing, you can see. So like in the selection sort, what we were doing, we were finding the minimum element interchanging with the first one. Okay. In the bubble sort, what we were doing, we were just comparing adjacent positions and then interchanging like according to order. So actually we wanted at the end the sorted list. Sorted list means increasing list. Okay. And in that bubble sort, that was bubble sort, like we interchange the consecutive position according to order. And then in insertion sort, we divide the list. Okay, list into two parts. So left part is sorted part, right part is unsorted part. Then you select first element from unsorted and you put into sorted part at the right position. Okay, so from here we'll start now searching. So searching, so let's see what is here. We will see how to find out whether a data value appears in the list. So we have to check, like you will have a given list and you will check whether that value is available there or not. If it is available, then you have to search at which position it is. So for example, given a list of names of a student in a class, we wish to find whether a particular name appears in the list. Okay, so this book actually takes example of list, and elements are names. That's why they are talking about names. So you may take numbers also, and then we may check whether that number is appeared in the list or not. So we will discuss two methods for searching here. One is linear search, other is binary search. Okay. So two searching methods we'll discuss: linear search and binary search. So as name suggests, okay, linear search is just linear. Binary search, like you will be. So we will see later on. Okay. First you see linear search. So in this method, we scan the list from the beginning till the required data value. What we do, we scan the list from the beginning till the required data value. So whatever value is required, you will scan that value, and each element you will compare for the search value. And so we scan the list from the beginning till the required data value is found or the list is exhausted. So like exhausted means if the data value is not found, so list will be exhausted and you will like print that value is not found or not available. This searching technique is known as linear search. So what is linear search? Actually, we scan the list from the beginning till the data value is found or the list is exhausted. So like we will compare each element of the list with that search value, and then we'll, if it matches, then we'll return that index. So here is the program. So before that, I would share it. 1 minute. Okay, so here you can see what. So let's come to the program. So we are defining a function, linear search. Okay, the inputs are list. So list will be given, and search value. So search value is the value we want to search. Okay, and we are running a for loop for I in range 0 to length of the list. So I is index. Okay, so I is index. I will take value 0, 1, 2, 3 up to length of the list. And if list I, so list value at ith index is equal to, double equal is there, we are comparing. So if list value at ith index is equal to search value, then you will return I. So you want that index at which the value is found. And then if it is not found, then return none. Okay. Now this is the main part. So list, we will be asking user to enter the list, and search value, we will be asking user to enter. So actually here, just you can enter the value. So eval is used to enter the list, but you may not write it. And then search result. So like linear search, this function we are calling. So the function we are calling here, this function. So this function we are calling here. So that function we are calling here. And list, so this list is here. And search value, so search value is here. So search value, you will be giving two inputs. One is the list, and inside that list what value you want to search. And then here we are printing that that search value found at index, and that index will be returned by that function. Okay, so suppose I will take one example. So suppose we take a list. Oh, okay. Suppose we have a list. You can take 3, 4, 5, 7, 9, 0, 1. Okay. So this is a list, and we want to search. So this is the list. And what do you want to search? Search value. Let's take. I want to search 9. Okay. So what we are doing here, for I in range 0 to length of the list. So what is length of the list here? So length of list here is 1, 2, 3, 4, 5, 6, 7. So length is 7. Okay. So length of list is 7. And so I is in the range 0 to length of the list. So I will take value I in range 0 to length of the list 7. Okay. So like I value will be 0, 1, 2, 2, 3, 4, 5, 6. In a start and end is not included. So I will take this value. Now we will be comparing. So we will be comparing if list I. So in the first iteration I is 0. So we'll check list at 0th index, which is here 3. So 3 is equal to search value. Search value is here 9. So no. So loop will go for next iteration. So this if condition is false for I is equal to 0. And then similarly it will take 1. So at first index 4 will be compared with 9. No. So if condition is false, so like next iteration. So like 5 will be compared with 9, 7 will be compared with 9. So we are scanning. First element we are comparing with search value, second element we are comparing with search value, third value we are comparing, fourth value we are comparing, and all for that if condition is false. So now when I reaches here, 0, 1, 2, 3, 4, when I is 4. So in that case, a list fourth index, list value at fourth index is equal to the search value, that is 9. So it is true condition now. So it is true condition. So it will return I. I is 4 here. So return 4. Okay. And list I have already given. So list I have given, search value I have given. So this it will do that. So output of this program for this list will be 4. Okay. So like you can try the program. So we're doing linear search. Okay. Uh, so these are linear search. Okay. This well, Hana, you can do. So any one program you can do, like this program you will try. Okay. So here what we are doing. So list, yes, this program you will try. Okay. So same program is here. We have defined a function linear search. Inputs are list and data. So data I have taken. You may write like search value. So data means the data you want to search. Okay. Or you may write the value you want to search. So like search value, if you want, you can write S value. I write S value means search value. Yes, you have to change everywhere then. Like here you have to write search value. S value means search value. Taking that variable, you may take your own variable. Okay, so like here list is list 3 that is given here, and we want to search Ruby. Okay, or you may write here and a search value like something, search value that we want. So which value you want to search? So like you want to search Ruby. Okay, and here you may write that. Okay, this, and here again list 1 I have given, and here I am searching 0, I'm searching 8. Okay, so if I run it now, so check. So for this print, there are 3 prints. So for this print, they are searching this Ruby in the list 3. So Ruby is found at index 2. Ruby is here, so index 2, 0, 1, 2. And in this list, it is searching 0 first. So 0 is available here. So at index 6. And 8 we are searching. That is not available here. So it will print none. Okay. So you just type this program. Quickly, everyone please write this program. If you have doubt, you may tell. No? So like you have understood, it is easy. Just a linear search. So we are searching linearly. And if I run for this example, like 1, 4, 3, 5, 7, 9, 0, 6. Okay, so here like length is 1, 2, 3, 4, 5, 6, 7, 8. Length of the this list is 8, and I is running in the range 0 to 8. Okay, so I will be taking value 0, 1, 2 up to 7. Length is 8. So it will take value till 7, and then it will be comparing. So list at index 0, so index 0, 1, 1 is equal to search value. So I'm talking about this example I'm discussing. So like 0, okay, search value 0. So 1 is equal to 0, no. 4 is equal to 0, no. So no means this if condition is false. So 3 is equal to 0, no. Here we are searching 0. 5 is equal to 0, no. So false. And 7 is equal to 0, false. 9 is equal to 0, false. 0 is equal to 0, yes. So here index like 0, 1, 2, 3, 4, 5, 6, 7. So at sixth index, this if condition will be true, it will return index. So index is 6. So that's why for this 0 we are getting 6 here. Okay. So this is very easy. 1 minute. One minute. So eraser here. Okay, so who have done? Okay, Rituraj. Yeah, what others? Please, everyone finish it quickly. You may write any one example. So, like I have taken 2 example. One list contains the names, and other list contains the numbers, and like that. Suppose here we want to search. So, like search value 1, I have taken Ruby, and search value 2. Suppose I take something that is not here. Okay, so like anything I can take. Okay, so suppose I take Sanjana, not here. So like search value 1 we are searching here, search value 2 we are searching here. So Sanjana, this I have taken Sanjana, search value 2, and search value 2 is not found, so that's why we are getting none. Okay. Okay, so Yeah, Sudeep, Ayush, only three. What was others? Quickly do it. You may write only one example. Either this one you may write, or this one you may write, or both you may write. It's up to you. But the main part is this: what we are doing. Okay? But like we are defining a function. This user-defined function, linear search, and then this is just we are giving the parameters here and calling the function. Only four people. Sorry, five people. This is a linear search. Just we are scanning each element of the list with the search value. And if it is found, then return I. If not found, then return none. So if I just now you may remove this. Just you can write that. So value one, you may write zero. Of course, if you write this much, is enough. Okay, Hansraj, so you can share a screen.
Oh, sir, I am joined with phone. It takes 1 to 2 minutes.
Okay, okay, so you can share next time, no problem. Suman, you can try.
Okay, sir.
Okay, so linear search and list and key, fine. So you have list this, you are searching 7. So 7 is that index, 0, 1, 2, 2. So, okay, where is the output? 2. Yeah, fine. Okay, thank you, Suman. Okay, so this is easy, right? Everyone can do easily. So next I will go to, uh, so this was linear search. Okay, so in linear search, in the list we are scanning each element of the list with the search value. Then if it is found, return that index. Next we have binary search. So binary search, what is binary search? So if the list to be searched is already sorted, so the condition required to apply binary sort is you have to check whether the list and where you are applying binary search is sorted. So the condition is like binary search you can apply only if the list is sorted. Okay, so if the list to be searched are already sorted, so binary search can be applied to a sorted list. Okay, and then we can use the faster method called binary search. Okay, so if it is already sorted, then we will apply binary search over that to search some value. So again you will have a list, that list will be sorted here, and in sorted list you will be searching some value or some key. Okay, so first we examine the middle name of the list. So like you have a list, so it is in ascending order, so it is sorted and we consider ascending order, okay, increasing order. So you first examine the middle name, so whichever the middle value, middle key in the list, so whichever is the middle value. Okay, and if it matches the name that we are looking for, we stop. So they are telling you algorithm. So like in the list, first you will find the middle value. So like suppose 0 is the first index, no, we start here and end is in -1, or first or last you can define, then you can take middle is equal to first plus last, or start plus end upon 2. Okay, so int value you can take, so you take middle index, then at the middle index if the value you are looking is found, then you just stop. Otherwise, if we do not find the name at the middle position, so like at the middle position the name or the value you are searching is not found, then we will only have to search on the left or the right side, since the list is ascending order, like sorted. So like we are considering ascending order. So suppose the search value is less than that mid value, so you will go into left side. If search value is more than the mid value, you will go into right side. So only you have to go into one side, and in each iteration you have to do the same thing. So here on if we do not find the name at the middle position, we will only have to search on the left or right side of the middle name, depending on whether the name at the middle position is greater or smaller than the name we are looking for. So you got the point. You will first search on uh, so like for example, suppose we have that list, okay, like 6 4 3 9 8. Okay, and we are looking for suppose we are searching here 4, so this is a list, and we are searching search value or key, you say, so key like you are searching 4 in that list. So what is algorithm? First you will check whether it is sorted, so no, so you cannot apply here, it is not sorted, right? So you will not apply here. First you have to sort it, otherwise you have to first sort it, है ना, using any one of the sorting algorithm, then after sorting then you can apply the binary search. Okay, so you will search it or you will take a sorted list. So let's consider a sorted list. So first you need a sorted list, so like 3 4 5 8 9. Okay, and we are searching the key 4. So what we'll do, so here we have 0 1 2 3 4. Okay, so middle index, this is middle value, or index is 2, so mid value is 5. So you will first compare that mid value is equal to 4. So answer is no, so no means false. So now you have to see whether you will search into right half or left half. So you will compare, okay, the key we are looking for is less than the mid value, so we'll go into left side. So we'll consider that left half of the list, 3 4. Again here you will do the same thing. So like now you can see, okay, 0 and 1, these are index. So what is mid value? So mid value you can consider this one or any one you can consider, it's up to you how do you define the middle. Okay, so suppose I take 0 plus 1 upon 2 and we take int value, so in that case it will return you 0. So 0th index we are considering middle, so mid value will be this. And again this 3 is not equal to 4, so now you will go to the right side of that, and now it is only single element. Now we compare, it will be found. So it, and you will find it. So that is the way. So it is explained there. So now what is saying? This is the way. First you will see the middle position. If it is the key value you are looking for, then we stop. Otherwise, we'll go into right side or left side depending on the value searching is less than mid value or more than mid value. So if it is less than the mid value, then we'll go into left half, or if the value we are searching is more than the mid value, then we'll go into right. Okay, Now here there is given to see how fast the binary search work. We only have to observe that every time search fails, the search interval is reduced by half. So like you are searching at middle and it is saying no, so means you will go into one half, either left half or right half, every time you are dividing by 2. I mean length of the list. So reduced to half, and thus in worst case we would, so this is not the part of that, because we are not discussing theories here. So just for information it is given, like the complexity here is log n plus 1 steps. It will not be considering this, we have to learn how to write the program. So now, okay, directly it is given the codes. Okay, let's see what it is doing. So we are defining a function binary search, and again the inputs are list, search value. Okay, so list it will be giving, and the search value, the value we are searching. Now here we have defined some variables like low, high, zero, length of list minus 1. So like zero is the low is the index, that is 0 here, and high is the index, length of the list minus 1. So you know already that if length is n, then the highest index can be n minus 1 index value. So while low is less than high, we are defining mid here. So mid, we are defining low plus high upon 2. So low index, high index upon 2, and it may be a fraction, so that's why we are considering int of that. So int value we are taking because mid will be only it will not be decimal. Okay, so it will be 0 1 2 like that. So if first, what you'll do, you will compare list at mid. So mid is the index. So at mid index, the value of the list is equal to search value. You will return mid. Okay. So first we are comparing the mid value with the search value. If it is found, then it is we return mid. Else, so there are elif because you will go into left or right. So that's why elif is used. So elif search value is less than the mid value. So see, search value is less than the mid value. So means you will go into left side. So what we are doing, we are reducing that high, that variable high to mid plus 1. Sorry, mid minus 1. So we are just taking the left half. So I will explain you with one example. I will explain you with one example. First, let's go through this code. So if it is search value is less than the mid value, you will go into left half. So left half means, so lower, like low index is same, just high index you will update, and that you will make mid minus 1. Else means if search value is more than the mid value, so you will go into right half. So in the right half, high variable will be remain same, and low you will update. So low variable you will update by mid plus 1, and if it is not found, then you will return none. Okay, and this is the this part is to check whether your list is sorted or not. So first we are checking here that list is sorted or not. So defining a function, we are defining a function is sorted if function, and the input parameter is list. For I in range 1 to length of the list, so you may take 0 to length of list minus 1, it's up to you. So we are just taking I1 to length of the list. If list at ith index is less than the list at I minus 1th index, so list at ith index means right value, and list at I minus 1 is left value. So if these are two consecutive value, so this is the right value and this is a left value, if you see from left to right. So like it is not in order, so they want to say if it is not in order, not in order means not ascending order, so then return false. So this is saying out of order, so they are not in increasing order or sorted list. Or if this is always false, then although this condition is always incorrect, if part, then it will return true. So true means list is sorted, if it return false, then it is not sorted. Okay, so this will return true, then we'll apply that. And half part is here. So next part is here. So list, we are asking the user to enter, and now if not is sorted means if list is not sorted, then you will print given list is not sorted. So is sorted, we're checking whether list is sorted or not. So if it returns false means it is not sorted. So if it is not sorted, then you will print given list is not sorted. Else, now then you will search the value. So first requirement for apply the binary search is list must be sorted. So first you will check that if it is not, you will print value not sorted. If it is sorted, then you are entering the search value that you are asking from user, and then printing that function. Okay, search value found at index this. So let me give you one example to apply. Okay. So suppose we take, and also I'm taking only increasing order. I mean list. So 2, 4, 8, 10, 11, 15. Okay. So this is a sorted list. So what we'll be doing? We are starting. We are defining a function binary search. Input is list. So this is the list, and search value will enter. So okay, search value. So since I have taken already sorted list, so this will return true. Obviously, this will return true. So search value. Suppose we are searching. What do you want to search? Let's say we are searching 15. Okay. So what is low? So here low in the beginning is 0. High. So high is the length of the list minus 1. So length of list is 1, 2, 3, 4, 5, 6. So it's a 5. Okay. And then if low is less than high, so yes, low is less than high. Then mid you will take 0 plus 5 upon 2. So 0 plus 5 upon 2, 2.5. You will take int value. So int value is 2.5 का int value क्या होगा 2. And now comparing list at mid index is equal to search value. So mid index is 2. So index here is 0, 1, 2, 3, 4, 5. So mid index here is 2, this, and value is 8 here. So it will compare whether this 8 is equal to that search value 15. So answer is no. So no means this if condition is false. This if condition is false. So false means you will go to next iteration. So next line is search value is less than list at mid. So search value is 15. 15 is less than the list at mid position. So I mean mid index. So that is 8. So this is also false. 15 is less than 8. No, false. So this will go to next line. So next line means else part. So else part means search value is more than the mid value. Yes. So now what we will do, so else part is correct. Okay. So here else part low will be updated. So now low value initially it was 0. Now low value will be mid plus 1. So mid is 2. So 2 plus 1 3, and high remains same. So high was 5 only. So means what, we have considered a right half, right of the middle, that mid index. So right part of the mid index. Okay. So we have taken that list, 10, 11, 15. Okay, that part. So now the list we have 10, 11, 15. We apply the same thing over this now. Okay. So again low is less than high. So again low is less than high. So in the next iteration mid will define. So now the mid will be 3 plus 5 upon 2. So 3 plus 5, 8 upon 2. 8 upon 2 is 4. So fourth index is the mid value. So this was third index, fourth index, fifth index. Okay. So this is the mid value 11. Mid value is 11, and mid here is 4. Mid is index. Index is 4. Again same thing. It will compare whether list at mid index is equal to search value. So that 11 is equal to search value 15. No. So this if is false. Next it will go to next line. So elif search value is less than the mid value. Search value is 15, less than the mid value is 11. No. So again it will go to next line. So else part. Now in the else part means search value is more than mid value. Yes. So that will be correct. So again, so next iteration I'm writing here. So we're writing in left side. Okay. So here the mid will be again sorry, low will be updated. Here the low will be updated by mid plus 1. So mid is 4. So mid plus 1 is 5. This is low. High will remain same, like, so high was 5 only. Okay. So means what, it considered again the right half of the right part of the mid value. So only list you have this now. Okay. So the index here is 5. So only value is this. So if you find the mid, okay, low is less than equal to high, equal is there. Okay, less than equal to high. So yes, equality is there. So low is less than equal to high, yes. So this while loop will run, it will not stop here. So mid you will find 5 plus 5 upon 2, so like 5 only. At fifth index you have 15. Now it will compare whether list at mid value is equal to search value, yes. So it will return mid. So return mid means here mid is 5, so it will return 5. So means at fifth index you find 15. Okay, so this is the algorithm, this way we are doing. So first you have a list, you will find mid value, compare with that. If it is not matching, then you decide whether you go right or left. Okay, so this we are doing for the increasing list. Okay, so like in assignment you have one question, do it for the decreasing list. So same thing here, just you will change the low and high, है ना? So if it is decreasing, then you will choose the other way. Okay, so I will show you now program. So this program in the book, so I have written. Uh, so binary search algorithm was this, like you will define a function, then list and search value. If mid value is search value, then search is है ना, search successful at mid. If है ना, if search value is less than that, you will perform in the left side the same thing, and then else if search value is more than the right, then you will perform the same thing right side. So this final program is this. Sorry, this is linear search. This one. Huh? Okay, I think I have to show it on ideally, so it will be better. Okay, so now it is visible, I think. Uh, yes. So you please write this program. So we are defining a function binary search. These are inputs. Okay. So the list we have 1, 2, 4, 6, 8, 12, and I'm searching that 12 here. So print search value found at index, and this is a function calling. So we are calling that function here. This function we are calling here. So it will return what? Index, or if it not found, then it will return none. So quickly write this program, and if it is working, just write in chat. Okay, so Rituraj are done. Others, please do. So, like हम क्या कर रहे हैं, जैसे मान लो कि low is here and high is here in the beginning. Value you can take 1, 2, 3, 4, 6, 8, 10, 11. Suppose. So low index is here, high index is here, and mid is here. So यहाँ होगा 0, 1, 2, 3, 4, 5, 6, 7. These are index. So 0 plus 7 upon 2 तो आएगा 3.5. So 3 ये मिड रहेगा. अब सपोज अगर हम राइट हाफ में मैं कोई वैल्यू सर्च कर रहा हूँ. So what we are doing, this we are assigning as low when we are searching into right side. ठीक है, this we are writing as low and that will be mid plus 1. ठीक है, high remains same अगर तुम राइट साइड में जा रहे हो तो. अब if you want to search into left side, so हम क्या कर रहे थे, like 1, 2, 3, 4. Then this low is as it is, just we are updating high, and high we are updating just, oh sorry, 4 is not है ना, so we don't have to write 4 here because we first compare with the mid. So we'll take left part of that. So if we consider left part of that, like the search value is less than the mid part, then we'll take this, and this we write as high, and that we take mid minus 1. That would take mid minus 1. Okay, so depends on you are going to right side or going to left side. So then binary search, binary searches we are. So this is when we consider right half. This is low and high even same. Okay, done. So Ayush and Rituraj is done. Okay, Ayush, you can share.
Okay, sir.
Okay. So you are searching 12. Okay, yeah. So 12 found at 5 index. Okay, fine, fine. Thank you, Ayush. So others please also finish. So in the list it is sorted, so this will give true, so we are writing of checking for false, so no. Then search value is 12, it will search value 12 found at that index, it will return. So how will it be working? Achha, you want to see this? So this you can see on Python tutor also. Like if I show you manually, you can see also. Like you take example, then manually you work, or you can see this here. So each step is how executed. You can check here. So the function we have defined two functions. 1 minute. Let me remove this. So we have functions binary search and is sorted. Two functions we have defined. List we have given this 1, 2, 4, 6, 8, 10, and then this is the list. So in the first iteration, I start with 0. So I is 0 here. The first iteration. Then it will be checking. So first here actually we have called binary search. In binary search, so it will be working from here, right? List and then each sorted. So first it is working inside that function. Each sorted. Here is the each sorted. Okay. So first they are checking whether each sorted returns true or false. You know? Then it will check whether this if condition is true or false. According to that, it will go into else or not. So it is checking. So like 1 is less than 2, 2 is less than 4, 4 is less than 6, 6 is less than 8, 8 is less than 12. So in all the cases, this if condition will come false. So it will come false means so finally it will return true. If condition will be false, it will not return false. I mean, so it will return the final return for this each sorted function will be true. So means this list we have taken is sorted. So this if condition will be false then, so it will go into else. This else part. So first it checked whether it's a sorted or not. So found it sorted, and here now it will come here search value, and else in else part it came. So search value is 12, and so in the here we are calling the function binary search, so it went in here in the function binary search, and now it will be applying that process. Okay, so we are searching 12. Oh sorry, I end. Yeah, so search value is 12, and it was like, so what is output? Index 5. Directly it executed. 1 minute. Yeah, so it started from here. Next. Yeah, so we are here now on binary search function. Okay, next. So search value is 12, n is 6, length of the list is 6, low is 0 initially, high is 5, mid will be 2. Then at second index we have 4, 4 is equal to 12, no, so it will go into elif part. Elif part means search value is 12, 12 is less than list mid value, no, so it will go into else again. Okay, so check. So low is updated by, so here low is updated, here low is updated mid plus 1, mid was 2, so low is now 3. Okay, so it is here again, it will go. So low is mid plus 1 3, so now it will consider this list only 6 8 12. Okay, and then in that it is again searching. So mid value is 8, mid value is 4 now. So mid is 4, at fourth index you have 8, it is equal to 12, no, so again it will go into right side, so it will update mid. Okay, so mid is 5 now because it was one value only, so and then return value 5. So at this fifth index it returned 5. I think everyone got the point. So what is being conveyed? Okay, so how it was. So if I tell you manually 1 2, this list I'm writing 4 6 8 12. Okay, so first low is this 0 index. So index 0, 1, 2, 3, 4, 5. So this is low in the beginning and this is high. So low plus high upon 2, so 0 plus 5 upon 2, so this mid will come this. 4 is equal to 12, search value we have 12. 4 is equal to 12, no. So then it will check whether search value is more than mid or less than mid. So more than mid, it will consider only right half. So only this part will be considered, 6, 8, 12. Index are 3, 4, 5. Now, so right half will go this part. So low, now this is low. Okay, mid plus 1, mid was 2, so index 3. And this is high, it will find mid. So mid is 3 plus 5 upon 2, 4. This is mid. Again it will check whether 8 is equal to search value, no. So it will go to next part. So next part, search value is less than mid value. Search value is 12, so 12 is mid value, mid value is 8, no. So again it will go next part. So low is mid plus 1. So again now it will go into right side, so only this part will be considered. And this will be low because mid plus 1, mid is fourth index. So mid plus 1, low is this, high is itself this. This is only high also, this is high also because high is 5. And mid, if you find here, so 5 plus 5 upon 2 is a 5 only, so mid is also 5. It will compare mid is equal to search value, yes, so this mid is being returned. Okay, so this 5 is the output. So this was binary search. Okay, this was binary search. So we discussed two searching technique here, linear search and binary search. So linear search you can apply over unsorted list also, but binary search you can apply on sorted list only, binary search. So before that you have to sort that. So like if I run this program, so already you have seen the output, I have shared it. Like, so so it's a binary search. So 12 found at, so 12 found at index 5, like it was so. Okay, so next we have, so this was two searching algorithm, binary search and linear search. Now we have next merge sort. So now we have two more sorting algorithm. Okay, so one is merge sort and other one is quick sort. So we'll start with the merge sort. Again here the purpose is to get a sorted list. Input will be unsorted list and output will be sorted list. So the merge sort algorithm is based on the divide and conquer. Okay, so this merge sort algorithm is based on divide and conquer strategy, that takes a list as an input and keeps on dividing it into two lists until a list of length 1 is obtained. So for example, so like if I will take one example, you might have seen all this thing in your data structure class, I think AD1 or AD2, AD1 I think. So so suppose you have a list 2, 8, 0, 1, 3, 5, 7. Okay, so this is unsorted list, you want to get a sorted list. So each time what you will do, each time dividing it into two lists until a list of length 1 is obtained. So how will divide, you will first again find mid, so like 0, 1, 2, 3, 4, 5, 4, 5, 6. Okay, so 3, so you may take, so what do you want to consider? So first half you may consider this one and next this. So first half will take this one 280. Again, it will depend on where you how you define mid. Okay, and next is 1 3 5 7. Then you will divide it to two part, like 2 here and 80 here. So mid actually we define the int value. So we take the float function, right? Float function of that mid plus low plus high upon 2, like in the binary search we were defined. We had defined mid. Again, you will divide it into two part, like 1 3. So 1 3, and here it will be 5 7, 5 and 7. Okay, then again here this is a single list of single element. Here you will divide into like 8 and 0, 8 and 0. Here you will divide 1 3, yeah? And here you will divide 5 7. So like that. So at the end you can see you have a list of single element. Now you have divided it. Okay, now you will start merging. So you will merge in order. In order means you will merge only sorted list. So from the end, like you will merge 8 and 0 first. So 8 0 will uni merge, so it will be 0 8. You will merge after sorting. Then 8 0 and 2, so it will be like 0 2 8. Okay, this you sorted. Then again here 1 3 is okay, 5 7 is okay. Then you will merge it 1 3 5 7. So it will be 1 3 5 7. Now you will merge this one 0 2 8 1 3 5 7. So it will make 0 1 2 3 5 7 8. And now you will get at least this. So here we divided, then we start merging. So we'll merge sorted list. So after sorting, we'll merge after sorting. Okay, so this you will get sorted list. So this was unsorted list, and then you will get sorted list. So divide and conquer. Okay, so divide until you get a list of length 1, and then you start merging, and merging after sorting. Okay, so look here what is saying. So this the merge sort algorithm is based on the divide and conquer strategy that takes a list as an input and keeps on dividing it into two lists until a list of length 1 is obtained. So like you have seen. Okay, and next point is it conquers the sorting problem by merging pairs of length 1 list to obtain the list of length 2. So like at the end you can see at the bottom we had lists of length 1. So you will merge two lists of single length, then it will make a list of length 2. Okay, then again you will be adding or merging them. Then after list of length 2 plus list of length 2, you will merge it. So you will get when you will merge pairs of list of length 2, so to obtain the list of length 4, and so on until the final sorted list of the size of the list original list is obtained. So you will get. Okay, so this is one example we have. 15, 12, 14, 17, 13, 11, 12, 16, 14. Okay, so what you are doing? So 0 is the low index, high index is 8. So like 0 plus 8 upon 2, 4. So mid minus 1. So you will take this, and from mid to end, you will take this. So 15, 12, 14, 17, you have taken one half is this, half is here. Again, you will divide it 15, 12, 14, 17, you will divide it 15, 12, you will divide 14, 7. Again, you will divide it 13, 11, and 12, 16, 14. Okay. So 0 plus 4 upon 2 is 2. So like 0 to mid, and then mid to end. So that you will take care. So 13, 11, and then 12, 16, 14. Then again you will divide. So this that length at the end you are getting the lists of length 1. Then check here at the end they have tested it. So here now you had this one. You have seen this at the bottom here. This, and how we are merging them. So now we are merging them. So 15 12 will merge like this 12 15. Okay, because we want a sorted list. This 14 17 will merge like this. and this both will merge in order. So 12, 14, 15, 17. Here again it was 16, 14, it will merge like 14, 16. When you merge with 12, so 12, 14, 16, and now you will this 11, 13 will merge 11, 13, and then you will merge these two. So you will get 11, 12, 13, 14, 16, and then you will merge this two. So at the end you will get a sorted list. So this is merge sort algorithm. And so what is the code for that? So this you have seen. Now you see the code. So we are dividing a function merge. Okay. So actually here is the merge sort. So two functions we have here. Like in the binary search, we had first we were checking list is sorted, and then we were uh, writing the function binary search. So here a merge function we are defining first, and somewhere you will find they define like that. So you may define anyone first. So merge function is so user defined function. The inputs are two list one, list two. So how this list? What are these two lists? So actually these two lists we will create from the original list. Zero to mid, mid to end, or mid to high. Like so, low to mid, mid to high, like that. So we'll define here. Here you can see. So like you may see here first. So we are defining a function merge sort, and input will be a list. Okay, list, that list we will ask from user. So merge sort is a function, and input parameter is list. If length of list is 0, like list contains no element, so it is already sorted. Or if the list has length 1, then it is also already sorted. It's a single element list, so it is already sorted. So then return the list itself. Else, so if it is of length at least 2, then we are defining mid. Okay, mid we are defining. So length of the list upon 2, integer division we are doing, length of the list upon 2. So like here if you see, so length was 9. Okay, so 9 upon 2, it was 4.5. So we are taking in integer value, so 4. Okay, so here, yes, any doubt anyone have? So what we are doing, list 1. So we are dividing the list into two part. Okay, the mid is the mid here we define this way. Okay, length of the list upon 2, integer division we are doing. And then we are applying that function merge sort recursion. Okay, this function we are applying over the list, and slicing is being used. So from index 0 to mid. Okay, so here end will not be included, so till mid. And then here mid to the last index. Okay, so we are dividing list into two parts. So that list 1 and list 2 is being used here. So here this that two, list 1 and list 2 are here. Okay, so first I started here. So mid we are defining in the list, then list 1 we are creating the left half. Okay, and we are applying the same function over that list. We will be creating list, and then this list contains what, initial start to like 0 to mid, and this mid to end. Okay, and then we'll return merge. So what is this merge function? So merge function we define here. So the merge function over that list, and here the merge function is defined. So merge function has two inputs, list 1 and list 2. We want at the end sorted list. So sorted list, we have taken an empty list in the beginning, and now we will be appending elements in that. So while length of list 1 is not 0 and length of list 2 is not 0, so both lists are non-empty list. And if list 1 at index 0 is less than list 2 at index 0, so at the end you can see here, so like here index was 0. Okay, so we are comparing both. So list 1 is here, list 2 is here, because over this function if you apply that merge function, so this is list 1, this is list 2. So we are checking whether it is less than that. No, so in that case, okay, so list 1 at index 0 is less than list 2 at index 0, then sorted list dot append. So in that sorted list you are appending smaller value. So whichever is smaller you are appending that first. So list 1 at index 0, and then list 1 dot remove that value. So after appending that value you are removing from the list 1. Okay, else means if list 1 at index 0 is not less than that, like here. So list 1 at index 0, this is not less than. So what you will do? So now you will append that smaller one. The smaller one here is list 2 at index 0. So sorted list dot append list 2 at index 0, and then you will remove that element from list 2. And this process will be continued, okay, till list 1 length and list 2 length are non-empty. It will be running till that. When it becomes 0, then it will stop. So here after that it stop, this will apply, it will be applying. We are removing every time list elements from list, no? So it will be doing. So similar way it will be merging, these two, then it will be comparing and doing. And if length of list 1 is 0, at the end when list 1 becomes empty, then you write sorted list is equal to sorted list plus list 2. So what element in list 2, you just add that. Else, so if length of list 1 is not empty, then sorted list is equal to sorted list plus list 1, and then we are returning at the end sorted list. So I will show you the execution over Python tutor. So 1 minute. uh, we have the program, right? Okay, so this is the function. Yeah, this is the program. Okay, so same program is here. So we define two functions, merge and then merge sort. Okay, and the list we have this. Suppose we have taken example 1 4 2 3, and then we are calling the function merge sort, and inside that merge sort we are using the function merge that we have defined here. So what we will be doing? So like here, if you see, so we have that list we have taken 1 4 2 3. So here we are calling the merge sort function. So merge sort is here, length is 0, no, length is 1, no. So this if condition is false, so it will work in else part, and then mid, so 0 1 2 3 mid. So mid we have length of the list. Length of list is 4 here. So length of list is 4. 4 integer division by 2. So that is 2. Okay. And list 1 will have now. So list 1. Here list 1 will have apply merge sort function. So list 1 will be 1 4. Okay. So 2 is here. Index 2 is here. So slicing is used. So 1 to 4, another part will be 2 to 3. Okay, and then same thing we are applying, same function we are applying here, merge sort. So here the same thing will be applied over this part also. So it will be 1, it will be 4, same function we are using here on this part. So it will be 2 and it will be 3. Okay, and now when list like becomes length 0 or length 1, so it will stop. So okay, so we got the list of length 1. Now what we are doing, we are calling returning what, merge over list 1 and list 2. So what is this merge? So it will come here, merge function. And now merge function over that list 1 and list 2. Okay, so this we have, now we have the list of single length. Okay, and initially the sorted list, this list is empty list. So we'll check length of list is not 0, while, so while loop is used. So when length of list 1 is not 0 and length of list 2 is not 0, if list 1 at 0th index list 2, so we'll first start from here. Okay, so 1 4 it is already sorted, and 2 3 it will and applied over both. Because merge sort is applied over both now, so it will be applying over both. So 2 3 sorted, now it will, you will sort it. So at the end when you will write it, so it will return you what, and it will compare the first element there and there. So it will return you 1 and 2, 3, 4. Okay. So we can see its visualization there on Python tutor also. The way. If I run it, so let me show you just running. So this program is merge sort. So the output is 1, 2, 3, 4. Okay, this will return 1, 2, 3, 4. And let's see it on here. So the function merge and then merge sort, there are two functions we defined, and list we have given 1, 4, 3, 2, 1, 4, 2, 3. Okay, this is unsorted list and we want sorted list. So they find it mid, length is 4, mid up 4 upon 2, 2. Then you check. So here this list is updated start to mid. So no, mid is 2, so end is not included. So like 0 to 1. So this is your updated list, and this function is merge sort is applied over that. So it will apply over recursion it is. Okay, so we are applying this function over that list. And then next, so again it will divide into two part. So mid one, so now it divided this one. Then again you will see. So when length is 0 or 1, it will return the length list. So that value is returned. Then it will apply over other part, this 4. Okay, next part. Then again this will come to the right half. Okay, now it will come to the this part. So you check here, right? It is sorted already. And now it is applied over this second one. So this is 1, 4 is, you are getting this after applying over this one. Huh? And then 2, 3 will be taken. And 2, 3 in the similar way. So applying that is here it will be sorted. Okay. So here you turn sorted list. So for that part you get 2, 3. Now for that part you have got here 4, 1, 4. Okay, that was list 1, 1, 2, 3. Here you get as a list 2. Okay, and now it will merge both. So see, so at the end they have these two lists. They have list 1 and list 2. This 1, 4 and this 2, 3 will be sorted. So this will be sorted, and 1, 2, 3, 4 is the output. The final output is this 1, 2, 3, 4. Okay, you may visualize also directly. So you first write the program, then you will visualize. So everyone please write this program. This is a merge sort. Okay. So manually how it is working, I will tell you. It is like this. Currently we have 1, 4, 2, 3. So you will divide in two part. 1, 4, 2, 3. Then you will divide 1, 4, 2, 3. Okay, and then you will be merging it. So it will be 1, 4 only, and it will be 2, 3 only. And when you merge it, so you will get 1, 2, 3, 4. So write this program. When you are done, you can write in chat. Okay. Okay, so Rituraj, Hansraj, Ayush, Arshdeep. Okay. So others please also complete it. Okay, who will share? So Ayush has shared already. I think Arshdeep you can share.
Yes, sir. So is my screen visible?
Yes, yes.
So this was the program.
Okay. Mm-hmm.
So after running it, I am getting the
Mm.
sorted list,
One, two, three, four. Yeah, fine,
sorted
fine.
marks
Yes,
list.
yes.
Okay,
Okay.
sir.
Thank you, Arshdeep. Yeah.
Thank you, sir. So can I stop share?
Yes, yes.
Okay, sir.
So those who are remaining, please also finish it quickly. Okay. So next part we have. So this was merge sort, and the last part of this course and this chapter is quick sort. Okay. So in merge sort, what we are doing, we are dividing the list into two equal parts, not equal like two half parts. Okay, half according to mid value we defined length of the list upon two. Okay. So like if length is like even, so it's obviously two equal part. If length is odd, then like one will have one more length, one part. So like we divide into two parts, then we divide, keep dividing until we get a list of length one. Then after that we merge it, okay, and matlab sorting. We merge it and then after sorting, so we get a sorted list at the end. So in quick sort, what do we do? So let's see what is quick sort algorithm. So quick sort is more efficient in terms of the space requirement as it does not need extra space for sorting. Okay, so it is saying that quick sort is more efficient in terms of space requirement as it does not need extra space for sorting. It works by, so we'll see how it works. So it works by choosing a value called pivot element. So here in a list, uh, in merge sort we were dividing on the mid value. Like here we have to select one pivot element. So it works by choosing one value called pivot element and using which we split the list to be sorted in two parts. And now according to that, using that pivot value, we will be splitting the list into two parts. So how will divide in two parts? The first part comprising elements smaller than or equal to the pivot element, and the second part comprising elements greater than the pivot element. Okay, so the two part are further sorted using quick sort. So like two parts you will have, according to that pivot element, and then again you will apply the same function over that part also. So two part are further sorted using quick sort in a similar manner. Okay, like you have done for the main list. So that both part you will apply the same function until the partitions of length 1 or 0 are left. Okay, so directly this code is given, and this part is not. This is actually merge sort only. So by mistake it is pasted here. Okay, so before telling the program, I will first show you how it works. Okay, so what happens actually? Like suppose you have a list. Like I have taken last example was what? 1, 4, 2, 3. Okay. So what we do, we select one pivot element. So in the book, like in different books or different places on Google, you will see pivot element selected in different ways. So in different program you may find. But this book do what? They select pivot element always last element. Okay, so we'll select pivot element as the last element of the list. Okay, so 3 is the pivot element. Now you will divide the list into two part according to, like you will select first part comprise elements smaller than or equal to the pivot. So you check the elements smaller than or equal to pivot, so like 1, okay, 2, I'm just writing like that. Okay, so what do we write? 1, 2, 3. Yeah, and the second list will consist. Second part comprise elements greater than the pivot element. So greater than the pivot, only 4. Okay. Again, you will like, but you will see here. Okay, this is sorted part. This is sort of like 3. It is a pivot. You will select here again. Then you will again apply over this function. At the end, you will just sort it. So I have taken it separately, but in the one part it will do, and then you will get a sorted list like that. Okay, I will take a larger example. So if we take different example, suppose I'm taking other example. Suppose I take example this one. So it is 12, 18, 17, 11, 13, 14. Okay. So what you do, like pivot element, you will select it. Okay. So it is not like we are divide. Okay. So first I will show you. So which are the elements less than or equal to 14? So 14 will be used as check first. So which are the elements less than or equal to 14? 12, 11, 13. Okay, and 14 itself. So this will come like this: 12, 11, 13, and 14. And you will then sort it, whether you have to sort it like, and after that you will have more elements. So the concept is when we have to bring that element into correct position. So we'll sort it also. So directly I'm telling you what happened. So 14 will be that pivot element. You have to bring that pivot element at the right position. Right position means the left part of that will consist of elements smaller than that, and right part will be larger than that. So like here you will write for 17 and 18, and here you will have 12, 11, 13. Okay, so this is not sorted part. So again you will apply over this function, same function you will apply. So at the end you will get sorted here. So this is sorted part, right part is, but here it is not sorted. So you will apply the algorithm. So I will tell you what is the algorithm. So you will get at the end sorted 11, 12, 13, 14, and 17, and then 18. So you will get that. So how we apply that function? So what is inside quick sort? Then I will tell you that. So this is the main part. You will select the pivot element, and you have to bring that pivot element at the right position. So right position means the elements less than that will be on the left side, and right in the right side the elements more than pivot will be there. Then again on right and left you will apply the same function, and you will then it will be like getting sorted every time. So okay, I will show you the program first, so that will. So let us understand this first. 1 minute. So I think this is not that algorithm. Okay, 1 minute. Let me explain that first. So what I'm trying in here. So just try to understand how it works. Okay. So like I have taken 11, and 22, 11, 88, 66, 55, 77. Okay, 33 and 44. So what I told, this is pivot element. I you start from here, j you start from here. So I will go left to right, and j will go from right to left. Okay. So what do you do? Like you select the first element which is more than pivot element, है ना? So like 88. So I is here, and you select the first element that is less than 44. So it was 44, na? So that is 33. So what you will do? Then we have to interchange these two value. So you will interchange ith, the value at ith index, value at jth index. So it will happen what? So it will be changed to, so how it is working I'm telling. Okay, so 88 will be, you will interchange it, because you want to bring that pivot element at the right position. So right position means pivot position at the before pivot element you will have elements less than pivot element, and at right side of pivot element you will have elements more than that. So, and 33 will be replaced by 88. So we are interchanging it. Okay, and 44 is here currently, and rest you keep as it is: 22, 11, 66, 55, 77. Okay, and now, so what is the next element more than pivot element? So 66, this here. So I will come here, and j was here initially, na? So next element less than pivot element. So which one you find less than pivot element? So whenever it will come here, so it will stop here. But we write that while I is less than j. So actually ij, what I am telling, there is a start and end. 1 minute. So first you understand in this, I will change the program according to that. So this I'm telling what I know. Okay, and the book they write in their own way, so I will explain that also. So I should be less than j. In that case, when like I becomes more than j, you will interchange that pivot, that I with p. So you will interchange that I with p whenever I becomes less than, when I becomes more than j. Okay, so usually I is left side, j is on right side. So you will interchange it, so you will get something like 22, 11, 33, and here 44 will come, and this 55 as it is, 77 as it is, 88 as it is, and 66 will come here. So what we did, we interchanged this I and p. We interchange this I and p. So just I'm explaining the algorithm. So now you can check 44 is at right position. Right position means uh, right to 45, 44 you have all elements more than 44, and left to that you have all elements less than 44. Is it? So now now what will do? So you have to apply on the left side and right side. So 44 is on right position, right? So you have applied that function over here and now here. So you have to apply that same thing here and same thing here. So now in that part again, so I'm doing it separately. 33, 11, and 22. Okay. And here you have 55, 77, 88, and 66. So you will apply both things, and 44 is the right position, so you don't have to change it now. Right position means it is at correct, yeah, position. So you just have to now sort this part and sort this part, so you will get at the end. So again pivot is here, I is here, j is here. So check the value more than pivot. There I you have to shift there where the value is more than pivot, so there is no other value, and j is itself, value at j is less than pivot. Okay, so in that case, so you have to interchange this. So how will sort it? So we need to sort it now. So which value will be interchanged? So apply over this. So I was a value less than 5 what is it? So here we were considering I, yeah, less than. So I will be increasing. So when this I is here, and I will increase to that point when list I is less than pivot, you will increase I. Okay. So that 22 is also less, 11 is also less. So I will reach here, and then you don't need to do anything here now. So you have to again divide that. So means what? Means 33 is at the right position. Okay. So since 33 is okay, you cannot interchange any. So you have to apply that over here, because actually we did not find any value more than 33 on left side. Okay. So 33 on right position. Then you have to apply the same thing over this 22 and 11, and then again this is pivot and this is I. Do we have time? Okay, time is also passing. So I and j, then the pi value is more than that. So I will be here, j is also here. So I is this, j is this. Okay, I is the first one, j is just before pivot. And since this value is more than pivot, so you will interchange it here. So I think I have less time to explain, so I will explain it in better way. So here it will be interchanged, how it is being interchanged. So I will explain next class. Tomorrow we have class now, so I will explain it. So it will get sorted according to that, and here again you will apply that. So you have to just bring the pivot element at the correct position. So what we have to do, we have to bring pivot element at the correct position, and then you consider left sub list and right sub list and do the same thing. So each time the pivot element will be coming to the correct position. At the end we will get the sorted list. So since we lost the time, so I will take attendance now. I will explain this in tomorrow again. So this quick sort algorithm I will explain again tomorrow. So today I could not explain well because now we have less time, so I will explain it again tomorrow. Okay, till then you may write the program. So I will be taking attendance, and if you want, because you have to write the program today or tomorrow. So this is a quick sort. So you may write till then. I'm taking attendance, okay, and I will explain it again tomorrow. So Alexander, Sahil, Shreya,
Yes, sir.
Anuja,
Present, sir.
Ujjwal,
Present, sir.
Anas,
Yes, sir.
Sangram,
Present, sir.
Sanjeevani,
Present, sir. Present, sir.
हाँ पुष्पांजलि,
Present, sir.
अनिल, मनीष,
Present, sir.
मयंक,
Present, sir.
शिवम,
Sir, Mayank present.
हाँ मयंक प्रेजेंट, ओके, शिवम,
Sir, Shivam present.
साहिल,
Present, sir.
ऋतुराज,
Present, sir.
रोहन,
Present, sir.
हर्षदीप,
Present, sir.
हाँ राहुल,
Yes, sir.
आंचल,
Present, sir.
हर्ष,
Present, sir.
राहुल चक्रवर्ती, अभिजीत, कोमल,
Present, sir.
अभिप्सा,
Present, sir.
अभिषेक, सुमन,
Present, sir.
आयुष,
Present, sir.
अभिस्मान,
Yes, sir.
शर्मिला,
Present, sir.
प्रेरणा,
Present, sir.
सुवानी, नीलम,
Present, sir.
अनिर्बन, प्रांजल, रुचि, राहुल,
Yes, sir.
प्रीतीश, अलीसा,
Yes, sir.
सचिन,
Yes, sir.
प्रयाग, रामाकांत,
Present, sir.
यश पटनायक,
Present, sir.
अनिकेत, अमलान ज्योति, हिमांशु,
Present, sir.
हंसराज,
Present, sir.
अयाज बेग, अपूर्व, करीना,
Present, sir.
मुस्कल, हर्ष,
Present, sir.
अंकिता,
Present, sir.
रोहित. Okay, so anyone left? So today we discussed that linear search,
Sir?
binary search. Yes.
सर अभी देखिए थोड़ा नेटवर्क खराब है मेरा सर.
क्या नाम? अभिजीत साहू,
अभिषेक बोईते.
अभिषेक.
Sir, Suwani also. 2818.
हाँ, अभिषेक प्रेजेंट है. सुवानी अच्छा, ओके, ठीक है.
रोहित और
अरे भाई तुम लोग रहते कहाँ हो? रोहित नारायण,
यस सर.
अभी सो के उठे हो? ठीक है, चलो. So in the next class we'll discuss this quick sort algorithm, and today we discussed linear search, binary search, and merge sort. Okay, thank you.
Thank you, sir.
Thank you, sir.